All right, so now let's go through kind of quickly the p-value approach to hypothesis testing for means. A lot of this is the same as the p-value approach to hypothesis testing for proportions. So if you want to go through the more in-depth explanation, please go back to the p-value approach to hypothesis testing for proportions video. I'm going to kind of skim over some of this because a lot of it is repeated. So the hypothesis test is the same process of assessing evidence provided by the data in favor of or against some claim about the population. For means, we are conducting a test about a claim involving quantitative data. And the population standard deviation is unknown. When we have both of those things, quantitative data, and we don't know the population standard deviation, we will be performing a one sample t-test for means. There are two ways we can test this, the critical value method and the p-value method. We will be focusing on the p-value method. So just like with proportions, in the p-value method, we will determine the probability of observing a test statistic as extreme as that we observed, or more extreme, assuming that the null hypothesis is true. So if our null hypothesis is a left-tailed test, so mu is less than some number, then we're looking at small. And the p-value is the probability of observing a test statistic as small as that observed or smaller. If the alternative hypothesis is right-tailed, so mu is greater than some number, then extreme means large, and the p-value is the probability of observing a test statistic as large as the one we observed or larger. And if the alternative hypothesis is two-tailed, then extreme means small or large. And the p-value is the probability of observing a test statistic as large in magnitude as the one that we observed or larger. So we look at both possibilities, the positive z-score or larger and the negative z-score or smaller. We determine if these results are significant by comparing the probability we found to a level of significance, also known as alpha. If our p-value, our probability, is less than our level of significance, then the results are too extreme to be possible, and we conclude that the alternative is true. If the p-value is not less than the level of significance, then we cannot say that the results are too extreme to be true, and we cannot conclude that the alternative is true. So this first case is where we reject the null hypothesis, and the second case is where we do not reject the null hypothesis. We have our fun rhyme. If P is low, reject HO. And then our steps for completing the p-value method. They're very similar, again, to that of a proportions hypothesis test. The first step is to give the null and alternative hypothesis. Then calculate the test statistic. This time our test statistic is a t-score. Calculate the p-value in step 3. And step 4, give the conclusion, either reject or fail to reject based on your p-value and your level of significance, and then interpret the results. And that interpretation should be in a form that anybody, regardless of their statistical knowledge, could read and understand. So again, I went through this pretty quickly because I'd already gone through a lot of the details in the hypothesis testing for proportions video. So if you need more of those details, especially in this middle section here on the left-tailed, right-tailed, and two-tailed, please go back and watch that video. But this is the process for doing a hypothesis test for means. So we're going to jump into the examples next.